Lesson 2.6a is finding quadratic models by hand. So far we've talked about linear models, which are y equals mx plus b in terms of their form. Used one looks like this, it's a line. We've done exponential, which is in the form y equals ab to the x, and these will either look like they're going like that, or they're decaying like that. For quadratic, our general form is ax squared plus bx plus c. This will be a parabola. Either going up, oops, it's not what I meant to do, going up, or going down. So first, we're going to graph a function. So if we look at y equals x squared minus 4x plus 3, a equals 1, since there's no coefficient in front of the x squared. B is negative 4, so we have our a is there, our b is here, and then our c is 3. Our line of symmetry is x equals negative b over 2a. So x equals negative b, or a negative 4 over 2 times 1. So that's a positive 4 over 2, which is 2. So our line of symmetry is x equals 2. You don't always have to draw it, but if we did, it would look like this. And this always is the vertical line of symmetry for our parabola. So now to find the vertex, we're going to plug our 2, because our vertex is going to be somewhere along that vertical line, into our initial equation. So f of 2 is 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3, which is negative 4 plus 3, or negative 1. So our vertex is 2, negative 1. Let's graph our vertex. Be about there. Up or down? Well, basically when a is greater than 0, the parabola opens up. It's kind of like a happy face. When a is less than 0, the parabola opens down. Kind of like a sad face. Keep that in mind. So in this case, since a is 1, it's positive. It's going up. And if you just think of what it looks like when it's going up, we see there's a minimum. Whereas if it was going down looking like this, there'd be a maximum. Now we'll find the y-intercept, which is when x equals 0. So we plug 0 into the equation. We'll get 0 squared minus 4 times 0 plus 3, which is 3. And our y-intercept is 0, 3. So we'll plot that as well. Last piece is our x-intercept. So this is when y equals 0. So this is when x squared minus 4x plus 3 equals 0. You can either use the quadratic formula or you can factor. So if we factor, we're looking at what numbers add to be negative 4 and multiply to be 3. That'll be x minus 3, x minus 1 equals 0, because negative 3 plus negative 1 is negative 4. Negative 3 times negative 1 is 3. And if we set x minus 3 equal to 0, add 3, we get x equals 3. If we set x minus 1 equal to 0 and add 1, we get x equals 1. So that means our x-intercepts are 3, 0, and 1, 0. And again, you could definitely use the quadratic formula here as well. So now we'll plot 3, 0, and 1, 0. And that's enough information for us to connect and make a pretty decent approximation of our parabola. Now let's look at another one. 2x squared minus 3x minus 2. So let's find the x and y intercepts. So for the x-intercepts, that's where y is 0. So we're going to have to set this equation equal to 0. So 2x squared minus 3x minus 2 equal to 0. You could factor. I'll show you quadratic formula for this one though. So the quadratic formula, and there's a song, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's lovely. Now it's immortalized in video. It's beautiful, isn't it? Okay, well, there's a song. So if we use that, x equals a negative 3, which is a positive 3, plus or minus the square root of negative 3 squared, so b squared, minus 4 times a, which is 2, times c, which is negative 2, all over 2 times a, which is 2 times 2. 3 plus or minus the square root. Well, this is negative 3 squared is 9. 4 times 2 times negative 2 is a positive 16. So it's 9 plus 16 all over 4. So 2 times 2 is 4. 3 plus or minus the square root of 25, which is 5, over 4. And we get to here, you split it. So one of our x-intercepts is 3 plus 5 over 4, 8 over 4, which is 2. And the other is 3 minus 5 over 4, which is negative 2 over 4, which is negative 1/2. So then our x-intercepts are 2, 0, and negative 1/2, 0. Okay, so let's plot those. 2, 0, negative 1/2, 0 is maybe about there. Our y-intercept is when x is 0. So we'll just do f of 0. And in our function here, when f of 0, we end up with 2 times 0, which is 0, minus 3 times 0, minus 2. So 0 minus 0 minus 2, which is negative 2. So our y-intercept is 0, negative 2. I'll plot that as well. So we'll tell if the parabola has a max or min point, and whether it fits its coordinates. So let's find our vertex. Okay, that's really what we're going to want to do here. Vertex. Because otherwise we're not really sure what our minimum value is. We kind of have an approximation, but we're not positive. So let's find our vertex. So first of all, though, since a is greater than 1, basically since a is positive, a is greater than 0. Sorry, where's it going? A is greater than 0. So it looks like this. It's going up and it has a minimum. And now let's find what it is. So x equals negative b over 2a. This will give us the x-coordinate of our vertex. So b is negative 3, so x is 3 over 2a, which is 2 times 2, which is 3/4, which is 0.75. And then to find the y value, we'll do f of 0.75, which is 2 times 0.75 squared, minus 3 times 0.75 minus 2. You're free to use your calculator for this, and you get negative 3.125. So then our vertex is 0.75, negative 3.125. So let's plot that as well. Maybe about there, and then there, something like that. There's an approximation of our parabola. Is it perfect? Definitely not, but it's good enough for our purposes today.